9 different kinds of trouble we call vibration mechanisms. The first one, called stick slip, is irregular drill string rotation. The vibration mode is torsional, as the bit stops rotating momentarily at regular intervals, causing the string to periodically torque up and then spin free at 2 to 15 times the average surface RPM, causing severe damage to the bit and BHA. The second mechanism is called bit bounce. It's the axial or longitudinal vibration of the drill string that typically happens with 3 cone bits in hard rock formations. Bit bounce damages the drill bit cutting structure, bearings, and seals, and results in flexing of the drill string, causing even more damage from axial and lateral shocks. Next is bit whirl. It occurs when the bit has cut itself a hole larger than its own diameter, allowing it to wander around in the wellbore instead of simply rotating around its natural center. Excessive side cutting creates an overgauge hole that, in turn, increases the tendency for the bit and BHA to continue whirling. Number 4 mechanism is BHA whirl. The eccentric rotation of the BHA around a point other than its geometric center in a complex motion, generating lateral displacements, shocks, and increased friction against the wellbore. Occurring as forward or backward whirl, it's the mechanism that constitutes the main cause of BHA and downhole tool failure. Next, lateral shocks describes what happens when the vibration mechanisms of bit bounce, BHA whirl, or modal coupling become so extreme they cause the release of energy built up in the drill string through sudden large lateral shock impacts. Unlike BHA whirl, where the motion settles to a steady state, in this case, the lateral shocks occur randomly. Torsional resonance is specifically drill collar torsional resonance and causes a juddering vibration of the drill string. It typically occurs in very hard rock being drilled with a PDC bit. Parametric resonance is our name for the severe lateral vibrations generated by axial vibrations caused by the interaction of the bit with the formation, which results in fluctuations of weight on the bit. Bit chatter is the high-frequency lateral and torsional vibration of the bit and BHA, caused by slightly eccentric bit rotation where there is cutter interference with the bottom hole cutting pattern. The cutters ride up onto the ridge between previously cut grooves and then drop back into the groove. Modal coupling describes vibration occurring in all 3 modes, axial, torsional, and lateral, simultaneously. It creates axial and torsional oscillations and high lateral shocks along the BHA. The most extreme form of vibration, it usually results from failing to control one of the other vibration mechanisms.